Hello guys, welcome to my online key fact in physics class. In our last video, we looked at Newton's second law of motion and simple basic problems associated with that law. But in this class, we'll be looking at the law of conservation of linear momentum. Law of conservation of linear momentum, we look at collision and the kinds of collision. So what does the law of conservation of linear momentum state that? The law of conservation of linear momentum states that in an isolated system of colliding bodies, the total momentum is always constant. So what does it mean for a system to be isolated? It simply means for that system to be closed. A system is closed or isolated when there is no external force acting on the system and the system itself is not acting on any external body. So that system is said to be closed. So a simple illustration of that law is when I have two colliding table tennis balls. I have the first table tennis ball with mass m1, second table tennis ball with mass m2. The first one is moving with a velocity u1 and the second one is moving with a velocity u2. So according to the law, the total momentum before the collision is equal to the total momentum after collision. So let's call this before collision. Before collision, the momentum I have before collision for this first body is simply m1 u1. Remember that in our last video we defined momentum as the product of mass and velocity. So we have mass, we have velocity, but initial velocity. Here we have m2 u2 before collision. So what is the total momentum before collision? It's simply m1 u1 plus m2 u2. So once this body collide, we'll have this same body m1, but it's assuming another velocity because collision has taken place. And as long as collision has taken place, a change in momentum has occurred. So we have v2, v1 now. Observe that the velocity is no longer u, it is now v. So m2 and v2. So this is after collision. So my momentum here is m1 v1. m1 v1. My momentum here is m2 v2. So what is the total momentum after collision? Is m1 v1 plus m2 v2. So according to the law that the total momentum before collision is always equal to the total momentum after collision in an isolated system of colliding bodies. So it means that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So in an isolated or closed system of colliding bodies, the total momentum is always constant before and after collision. So this is what we have. So we could have situations where this sign will change. If, for instance, this body and this body are colliding in opposite direction. So I throw a table tennis ball like this, another person throws another table tennis ball coming my direction. When the two collide in this direction, this sign becomes negative. But if they collide in same direction, the sign remains plus. So I could have another formula that m1 u1 minus m2 u2 is equal to m1 v1 plus m2 v2. Please, here is positive. It doesn't change. So I hope this makes sense. So this will lead us into the kinds of collision. So kinds of collision, we simply have two kinds of collision. The first one is the elastic collision. The second one is the inelastic collision. Elastic and inelastic. So for elastic collision, the momentum is conserved and the kinetic energy is conserved. It means that the total momentum before collision is equal to the total momentum after collision. and the kinetic energy before collision, the total kinetic energy before collision is also equal to the total kinetic energy after collision. So this simply means that both energy and momentum is conserved in the elastic collision. The difference between the elastic and the inelastic is that in the inelastic collision, the momentum is conserved, but the kinetic energy is not conserved. So there's a slight difference in formula when you are looking at elastic and inelastic. So the two formulas, the basic formulas for elastic collision is, for elastic collision, the formula is M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2, which is what we stated initially. But this sign can change depending on whether the bodies are colliding in opposite direction or in same direction. So same thing as the kinetic energy is always conserved. The kinetic energy for the elastic collision is given as 1/2 M1 U1 squared plus 1/2 M2 U2 squared is equal to 1/2 M1 V1 squared plus 1/2 M2 V2 squared. That's the kinetic energy. Is also conserved. But for inelastic collision, what happens? There's a slight change in the formula for inelastic collision. In elastic. So in the inelastic collision, these two bodies, they collide and they move together with a common velocity. So you would have that for inelastic collision, that V1 is equal to V2 is equal to V. So this V is same thing with V1 and V2. So you find V replacing V1 and V2 in the inelastic collision. So the formula will be okay, we have, let me illustrate it with this. Let's say this M1 U1, let's say M1 U1, M2 U2, they collide together. So after collision, they stick together. This is M1, this is M2, and they move with a common velocity V, no longer individual velocities of V1 and V2. They move with a common velocity V. So that is why we are saying that V1 is equal to V2 is equal to V. V is replacing V1 and V2 because V is the common velocity for both of them. They stick together and they move with common velocity. So the formula changes to M1 U1 plus M2 U2 is equal to M1 plus M2 open bracket V. That's what the formula becomes. So the kinetic energy is 1/2 M1 U1 squared plus 1/2 M2 U2 squared is equal to 1/2 open bracket M1 plus M2 close bracket V squared. So in the case of inelastic collision, the basic difference between elastic and inelastic collision is that in the inelastic collision, momentum is conserved, kinetic energy is not conserved. These two bodies, they stick together and move together with a common velocity. But for the elastic collision, both momentum and kinetic energy is conserved. So I believe we've been able to pick one or two from these formula derivations. In our next class, in our next video rather, we'll solve problems. Thank you for watching.